So today we're talking about lesson 7.4, parallel lines and proportional parts. Last week and this week we talked about the things that similar triangles or similar polygons had in common. And remember we said that, if two triangles or two polygons are similar, what's true about their sides? They're proportional, right? They're also proportional to the scale factor, which is the ratio of a pair of corresponding sides. What else are the sides proportional to? Medians. What else? The angle bisectors. The what? The heights, the altitudes. Okay. One more thing. The what? The perimeters, right? So all those things are proportional to each other. Well, today's lesson, instead of comparing two similar triangles, we're comparing some proportionalities that happen within a single triangle, okay, when certain things happen. So that's what we're talking about today. And our first theorem is the triangle proportionality theorem. And it says that if a line is parallel to one side of the triangle and intersects the other two sides, then it separates the sides into segments of proportional lengths. Okay, so we notice here on our triangle that BD is parallel to AE. Okay, so and BD intersects both sides of the triangle. And so what this says is if that happens, then these two sides here are broken up into proportional parts. So like A is to AX as B is to BX. Okay? So if BD, and BD has to be parallel to AE in order for this to happen. So if BD is parallel to AE, then you can set up a proportion. CD is to BA as CD is to DE. You can also go back and forth. You could also do CB is to CD as BA is to DE. So you can also do it like that, okay? And this happens when you've got this segment here that's parallel to the third side, okay? And it intersects the other two sides of the triangle. So let's do some examples here. It says in triangle EFG, HL is parallel to EF. EH is 9. HG is 21. FL is 6. And LG is X. Okay, because that's what we're looking for. So what can we do here? Set up a proportion. What should it look like? Okay, good. 9 is to 21 as 6 is to X. Okay, and so if we cross multiply, we end up with 9X equals 126. We divide both sides by 9, and X ends up being 14, which is also the length of LG, which is what we're looking for. Okay, questions on what we did there? All right, now, the next theorem we want to talk about is the converse of the triangle proportionality theorem. Okay? And basically this one works backwards. It says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side. Okay, so what that says is that if this line BD is parallel, if this line BD breaks the two sides of the triangle into proportional parts. Okay, so if this happens, A is to AX as B is to BX. If that happens, and this intersects both sides of the triangle, then you can say that these two lines here are parallel to each other. So, if these parts are proportional, CB is to BA as CD is to DE, then I can say that BD is parallel to AE. So it's kind of working backwards. The first one proves, if you know the lines are parallel, then it proves those parts are proportional. Okay, this one says, okay, well if these parts are proportional, then I can say that the lines are parallel. Okay. All right, so let's do an example. It says in triangle HKM, HM is 15, HN is 10, JK is half of HJ. So JK is half of HJ. How should we represent that? Okay, we could do that. All right. So you're going to let this be X, and you're going to let this be 1/2 X. Okay, we could do that. We could do that. Okay. So now I wanted to see if these two lines are parallel. In order for these lines to be parallel, these parts have to be proportional. Now, this whole thing here is MH is 15, NH is 10, so what does that make MN? Huh? 5. Okay, so now I can determine if these sides are proportional. And on this one, you can kind of just look at it and see, because 5 is half of 10, right? And this is 1/2 X is half of X. You can set up the proportion and solve it. I want to show you what that would look like. You could 10 to the 5 as X is to 1/2 X. And if you cross multiply, you would get 5X equals 5X. Okay, so if it's not real easy to see, you can actually multiply it out or cross multiply, and you can determine that. Okay, so we could say that NJ is parallel to MK, and it's by the converse of the triangle proportionality theorem. Now let me ask you this. This is just kind of a side note. You chose this to be X, this to be 2X. Could I have done 2X and X? Could I have done that too? Then it might be a little bit easier, like especially if we're doing thirds or something like that. But you know, it would have been third, it would have been 3X and X. So that's another option that you could have done there. Okay? Alright, so either one works. Alright, the next thing we want to talk about is the midsegment of a triangle. Back in the chapter on quadrilaterals, we talked about a midsegment of a trapezoid. Well, this has a lot of similar characteristics. A midsegment of a triangle is a segment of a triangle whose endpoints are the midpoints of the two sides of the triangle. Okay? So you see here that A is the midpoint of PQ, and B is the midpoint of RQ. Okay? And so if we connect those, we get the midsegment. And it was, you know, the same was true with the trapezoid, the midsegment of a trapezoid. It connected the midpoints of the legs of the trapezoid. Well, this connects the midpoints of two sides of the triangle. All right, so we have the triangle midsegment theorem. And it says, a midsegment of a triangle is parallel to one side of the triangle, and its length is half the length of that side. So, again, this is my midsegment right here, and it says that this is half the length of PR. So AD is half the length of PR, and it's parallel to PR. So its length is half that of the third side, and it's parallel to the third side. Okay? Now, don't forget about, you know, when you've got parallel lines like these here, that, you know, you've got corresponding angles that are congruent, that might come into play. You know, don't forget about all the rules with the parallel lines, the special angles that are formed. Okay? All right. So let's do a couple of problems here. It says, in the figure, XY and XZ are midsegments of triangle RST. So this right here is a midsegment, and this right here is a midsegment. Okay? Find each measure. So they want me to find XC, okay? And XC, if this is a midsegment, okay, this is the third side, all right? What relationship does this midsegment have with the third side? It's half of it, right? So if the third side is RT, then what's XC going to be? 6.5. Okay. Now we want ST. Okay, here's ST. This again is a midsegment, so what relationship is going to happen here? What's ST going to be? be 2 times 7, right? Which is going to be 14. Good. All right. Now we want to find the measure of angle RYX. This right here is RYX. Right there. Okay? Now, this angle is created, or we have a pair of parallel lines here cut by a transversal. What kind of relationship do you see going on there? Alternate interior angles. And what do we know about alternate interior angles? They're congruent. So angle RYX is 124 degrees. Now, it might be hard to see, but do you see how I kind of highlighted it? It makes it pop out just a little bit more. So, look at what creates the angles that you're working with and highlight it. Redraw it on your paper would be the better thing to do, but so we don't draw on our books. But all right, couple of corollaries here. The first one says that if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So notice here that we've got AD, BE, and CF. Those are all parallel to each other, okay? So that's 3 or more lines that intersect 2 transversals. And what that says is it breaks the parts into segments of proportional length, okay? So like A to AX as B is to BX. Okay, so I've got those 3 lines that are parallel to each other. And you can set up really a lot of different proportions here. I'm going to show you a couple of them. You can do AB is to BC as DE, that's a terrible E, DE is to EF, that's one. You could go across, AB is to DE as BC is to EF. You could even do little to big, like AB is to AC. AB is to AC, and then DE is to DF. Or you could use this little part to the whole thing too. I'm not going to write them all down. There's lots of different things that you can do there. Okay? So this happens when you've got 3 or more parallel lines that intersect 2 different transversals, and those transversals are cut off into proportional lengths. Alright, so look at this example. It says in the figure, Larch, Maple, and Nuthatch streets are all parallel. So, Larch, Maple, and Nuthatch, that's hard to say, Nuthatch streets are all parallel. The figure shows the distances in between the city blocks. Find X. What do you think? This right here is 26, this is 13. I don't know what this is, and this is 16. What do we have going on here? Do these segments have a relationship? You can definitely see they're not equal, right? So what are they? They're proportional, okay? So what would my proportion look like? Okay, good. 26 over X as 13 is to 16. Could you have done 26 is to 13 as X is to 16? You could have done that too, right? Okay. All right. So if we cross multiply there, we get 26 times 16. That's 416 equals 13x divided by 13 is going to be 32. Is that right? And really, this one's not so bad because you can see this is a 2-to-1 ratio, right? So this would need to be a 2-to-1 ratio also. And since this is 16, that's going to be 32. So some of them are easy to see. Depends on what numbers they give you. All right, last little thing here. And this is very similar to the one above. It says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So in the corollary above, it said if you have 3 parallel lines that intersect 2 transversals, then the transversals are cut off proportionally, correct? Well, this is saying that if the proportion is a 1-to-1 proportion on one, it's going to have to be a 1-to-1 proportion on the other, yes? So if these two, if these lines are parallel and you've got cut by 2 transversals, if these 2 parts are congruent, then those 2 parts are going to be congruent. Okay? And so now they want us to find the value of x and y. So what would we do to find x? Set those two equal parts equal to each other, right? Those two congruent parts. So we would do 3x minus 4 equals 6 minus 2x. And so that gives me 5x equals 10. And so x is 2. And then to find y, basically the same thing, right? These two parts here are equal to each other. So I'm going to set 5/3 y plus 1 equal to 3y. And so, what should I do? Get rid of the fraction. How can I get rid of the fraction? Multiply both sides by 3. Okay, so I end up with 5y plus 3 equals 9y. I'm going to multiply each part, okay? Subtract 5y from both sides. That gives me 4y. Divide both sides by 4. And y is 3/4. So x is 2 and y is 3/4. Okay, so real quickly, let's recap this. The triangle proportionality theorem said that if you have a segment of a triangle that's parallel to the third side and it intersects the two sides of the triangle, what does it do to those sides it intersects? It breaks them into proportional lengths, right? And then the converse of that's true. If you have a segment that breaks those sides into proportional lengths, then what's its relationship to the third side? It's parallel, okay? Let's see. We talked about a mid-segment, okay? A mid-segment connects the two midpoints of the sides of the triangle. And what is that mid-segment's relationship to the third side? It's half the length, right? And it's also parallel to it, right? It's also parallel to it, okay? So, it's half the length of the third side, and it's also parallel to the third side. Okay, we did some problems on that. And then we said that if you have 3 or more lines that are parallel, cut by 2 different transversals, it breaks those parts into segments that are proportional, right? And if those segments happen to be congruent on one of them, then they're going to have to be congruent on the other one, right? Because they're proportional, right? So if this is a 1-to-1 ratio, that's going to be a 1-to-1 ratio, okay? All right, any questions? Nope. Okay, your assignment is on the board.